Assalamualaikum. Let's learn Chapter 3, Electrostatics. What is electrostatics? It is a branch of physics that studies electric charge at rest. Electrostatics come from the word electro, which means electric charge, and statics, which means the electric charge at rest. For this chapter, we are going to learn about electric charge, Coulomb's law, electric field, moving charge in a uniform electric field, electric potential and potential difference, and electric potential energy. What is electric charge? So actually electric charge comes from the smallest particle called atom. All matter around us is made up of particles called atoms. And you can see your table, your chair, your book, your pen is all made up of atoms. When we look more details, this atom has atomic structure. It's made up of electron, proton, and neutron. So atom consists of two types of charge. First, positive charge or known as proton. Second one, negative charge or known as electron. Opposite charge will attract and like charge will repel each other. How to know whether the object is positively charged or negatively charged? A positively charged object, it has more protons, while negatively charged object, it has more electrons. Meanwhile, we have neutral charged object, which means that the object have the same amount of protons and electrons. According to law of conservation of charge, charge is neither created nor destroyed. It can only be transferred from one system to another. For example, we have a balloon, which is we wrap it with a wool cloth. When the two objects touch, the negative electric charge can be moved from one object to another. Thus, the balloon will become negatively charged object and the wool cloth become positively charged object. When the balloon becomes negatively charged object, we put the balloon near to a wall. What will happen is the balloon will stick to the wall. What makes the balloon stick to the wall? Because of the negative charge on the balloon will attract to the positively charged on the wall. In time, the charge will move around and the balloons will become neutral again. It is no longer attracted to the wall, so it will fall. Have you ever experienced electrostatic or static electricity? So I believe when we use the trolley in the mall, sometimes we will feel a bit of shock of electricity when we touch the moving trolley. The other example is when we move across a carpet, the negative charge from the carpet goes to you due to friction, and your body is now built up of negative charge. The negative charge are kept in our body until we touch something. That's why when we touch a metal knob, the shock that you feel is the fast transfer movement of negative charge from your body to another object. This movement of charge is known as electrostatic discharge or discharge of static electricity. But don't worry, it's just for a while, and in time, both of the objects will become neutral again. The other example of the electrostatic effects are shown in the figure below. Not all discharge of static electricity result in small shock. We have lightning, which is a phenomenon that associates with electrostatic discharge. So what happened during the lightning? The friction that occurs between the storm cloud, water droplets, and the air will cause the cloud to be charged with electrical charge. And lightning occurs due to the attraction that exists between the positive charge on Earth and the negative charge on the cloud. The lightning phenomenon has been described in the Quran from the Surah The Light or Surah An-Nur verse 43. Allah has described about the lightning phenomenon, and the scientists use this lightning phenomenon as inspiration to learn about the electrostatic and also the electric current. Okay, quantization of charge is the method how do we measure the amount of charge on a charged object. So the symbol for the amount of charge is Q. We can use capital letter Q or small letter q. And Q is equal to NE. N is the integer number. It depends on how many protons or how many electrons in that charged object. And E is the fundamental amount of charge. For both proton and electron, they have the same value, which is 1.6 times 10 to the power of negative 19 Coulomb. You can get the value of fundamental amount of charge by using your scientific calculator. Just press constant 23, then you will get the value of E. Amount of charge Q is a scalar quantity, thus we will only get the magnitude, and the unit is Coulomb, capital letter C. Let's try this example, 3.1. A. If there are 5 electrons in a charged object, so its total charge can be calculated as, we are going to use the equation Q equal to NE, N is equal to 5, meanwhile E is 1.6 times 10 to the power of negative 19, then you will get 8 times 10 to the power of negative 19 Coulomb. B. When two objects are rubbed with each other, approximately a charge of 280 nanocoulomb, this is Q, can be produced in each object. Calculate the number of electrons that must be transferred to produce this charge. We want to find N. So by using the equation Q equal to NE, then we rearrange it into N equal to Q over E. Substitute Q, 280 nanocoulomb, and E is 1.6 times 10 to the power of negative 19. Then you will get there are 1.75 times 10 to the power of 21 electrons on each object. Coulomb's law. Between the two stationary charged particles, let's say we have positive and negative charge. Between them, we know that there are repulsive force. But what is the value of that force? So we can use Coulomb's law to measure or to determine the value of the repulsive force or attractive force. So Coulomb's law is actually define the force between these two charges. Coulomb states that the magnitude of an electric force between two separated charges is proportional to the product of the magnitudes of the charge and is inversely proportional to the square of the separation between them. This statement defines the equation here, which is actually force is directly proportional with magnitude of the charge and inversely proportional with the square of separation between them. So if we want to make it the equation become equal, we need to put a constant right here. So it will be F equal to K Q1 Q2 over R square. K is Coulomb constant, 9 times 10 to the power of 9 Newton meter square per Coulomb square. And R is the distance between two charge, not radius, okay? It's distance, jarak di antara dua charge tersebut. Electrostatic force or Coulomb force is a vector quantity that has both magnitude and direction. So to find the magnitude, we use the equation F equal to K Q1 Q2 over R square. But to find direction, we need to determine it based on the charge. It's either positive positive or positive negative. Check whether they are attract or repel, and from that you can determine the force direction. The direction of force is depend on whether the charged object are charged with like charge or opposite charge. So kalau like charge, they are going to repel. Meanwhile, for the opposite charge, they are going to attract. The unit for force is Newton, and no need to substitute the sign into this equation because this equation kita nak dapatkan magnitude sahaja. So kalau kita pakai negative charge, tak perlu substitute negative sign into this equation. Negative sign too will help us to determine the direction of the force. The value of Coulomb constant K is 9 times 10 to the power of 9. So it actually comes from this equation. Okay, dia derive daripada equation ni. K equal to 1 over 4 pi epsilon naught, where epsilon naught is 8.85 times 10 to the power of negative 12. This is permittivity of free space, which is a physical constant that represents the capability of a vacuum to permit electric field. When we do experiment, kita mesti nak pastikan the situation or the area or the condition is constant. We want to make sure that the condition is not affected by surrounding. Hence, the formula of Coulomb's law is actually be written as F equal to, in bracket, 1 over 4 pi epsilon naught times Q1 Q2 over R square. But since we already calculate the value of this one, kita dah simplify it, it become K or 9 times 10 to the power of 9. So tak perlu nak gunakan ini dah, sebab kita dah already calculate in this bracket to make it as a constant K. Based on the equation, we can also determine the relationship between force and also R. You can see that the greater the distance between two static electrical charge, the lower the electrostatic force between them. Semakin jauh jarak di antara dua charge tersebut, maka makin kuranglah dia punya force. Maybe dia punya attractive ataupun repulsive force berkurang. Tapi semakin dekat kedudukan these two charge, so dia semakin kuatlah dia punya force. Kalau attract, dia semakin kuat attract. Kalau repel, dia punya repulsive force semakin kuat. If we compare the relationship between force and also 1 over R square based on this equation, we can see that we will get a straight line graph. So why don't we compare this equation F equal to K Q1 Q2 over R square with Y equal to mx, the straight line equation. We can see that on y-axis we have force, x-axis we have 1 over R square. Thus the gradient is equal to K Q1 Q2. Since electrostatic force is a vector quantity, magnitude we can determine by using the equation F equal to K Q1 Q2 over R square. Meanwhile, the direction can be determined based on their charge. For example, we have positive and negative charge. So, we can label the force exerted on this charge due to this charge. Ataupun kita boleh katakan F12, force yang bertindak ke atas charge Q1 disebabkan oleh charge Q2. Kalau tak ada charge Q2 ni, maka tak akan ada pun force dekat Q1. So, you can label it as F12. The direction will be to the right because they are attract. On Q2, they are F21, or we can say that force exerted on charge Q2 due to charge Q1, the direction is to the left because attractive force. Based on this diagram, you can find F12 equal to K Q1 Q2 over R square. And you can also calculate the value of F21 K Q2 Q1 over R square. You can see that actually the equation are the same. Thus, you will get the same answer. Di mana nilai ataupun magnitude F12 sama dengan F21 equal to F equal to K Q1 Q2 over R square. They have the same magnitude but different direction. F12 to the right, F21 to the left due to the attraction force. The other example is, if we have two positive charge, we know they are going to repel. So when they repel, the direction of force on charge 1 due to charge 2 will be to the left. Meanwhile, the force on charge Q2 due to charge Q1 will be to the right because they repel. What about the magnitude? The magnitude you can calculate based on this equation because they have the same value. Take note that the sign of charge can be ignored when substituting into the Coulomb's law equation. Okay, tak kisahlah dia positif ke, dia negatif ke, you can ignore the sign. The sign can be used to determine the direction of the force. What if we have more than two charge? Thus, we need to find the resultant or total electrostatic force that exert on that charge. Okay, for example, the first diagram, we have three charge, Q1 positive, Q3 negative, and Q2 positive. There are distance between them, R1 and also R2. If I ask find the resultant electrostatic force that exerts on charge Q2. Bermaksud saya nak cari berapakah jumlah electrostatic force yang bertindak ke atas charge Q2. Okay, what we are going to do is label the force that exert on this charge. Okay, Q2 and Q1, positive and positive charge, they are going to repel. So this is F21 and this is F12. Meanwhile, Q2 and Q3, negative and positive, they are going to attract. So this is F32, F23. Since we only want to calculate the value on this second charge, let's focus on this charge only. F21 and F23, they will not have the same value because F21, the equation is K Q2 Q1 over R square. And F23 is K Q2 Q3 over R square. So how to find the resultant? Then you can minus F21 minus with F23 because they have different direction. If the question asks to find the force exerted on charge Q1 contohnya. So the force act on charge Q1 is F12 and also Q1 and Q3 is positive negative attract. So there will be F31 right here. Sorry, F1. So there will be F13 right here to the right. So find the value of each force, then find the resultant force. This example if the charge are on the same axis. But what if the charge is on different axes and have angle between them? For example, on the second diagram, we have three charge, Q3 negative, Q1 negative, and Q2 positive charge. Let's say I ask find the resultant force exerted on Q2. Okay, so focus on Q2. Q2 and Q1, positive and negative, they are going to attract. So this is F21. Q2 and Q3, they are positive and negative, they are also going to attract. So they akan attract macam ni. F23. Okay, then you need to find the angle right here. Okay, transfer it into X and Y axis. The force is at this position on the second quadrant. Let's find the resultant vector or resultant force based on this XY axis. Example 3.2. We have 2-point charge Q1 equal to positive 1 times 10 to the power of negative 8 coulomb. Q2 positive 3 times 10 to the power of negative 8 coulomb are separated by a distance of 2 mm. So this is R, this is Q1, Q2. Determine the magnitude and direction of the electric force exerted on each of the charge. So we have 2-point charge and they are on the same axis. So label the direction of force between them. Let's say on the first charge, positive and positive. So force on charge 1 due to the charge 2 will be directed to the left. F12. Meanwhile, force on charge 2 due to charge 1 will be to the right because they will repel. Okay. So we are going to use the equation F12 equal to F21 equal to K Q1 Q2 over R square. Substitute K is 9 times 10 to the power of 9. Q1 is 1 times 10 to the power of negative 8. Q2 3 times 10 to the power of negative 8. Divide with R square. R is 2 mm. Convert it into meter. You will get 0.675 Newton. This is the magnitude. What about the direction? Due to repulsion force or repulsive force, the direction of F12 is to the left and F21 is to the right. Example 3.3. We have 2-point charge Q1 positive 2 nanocoulomb, Q2 positive 5 nanocoulomb, situated at a distance of 3 cm and 4 cm from a third charge Q3 equal to negative 5 nanocoulomb situated between them. In between Q1 and Q2, there is Q3, where the position of Q1 is 3 cm from Q3 and Q2 is 4 cm from Q3. These three are situated along the same axis. Calculate the resultant magnitude and direction of the force that exerted on charge Q2. So focus on charge Q2 only. What are the force exerted on this charge Q2? The first one is, we have force exerted on charge 2 due to charge Q1. So they are going to repel, positive, they are going to repel like this. And between charge Q2 and charge Q3, we have attractive force. So focus on Q2 only and find the individual force. What is the value for F21 and also F23? For F21, KQ2 Q1 over R square. So we can substitute the value. K is 9 times 10 to the power of 9. Q2 is 2 times 10 to the power of negative 9. Q1 is 5 times 10 to the power of negative 9. And the distance between them, you can measure based on this diagram. 4 plus 3 centimeters, so it will become 7 centimeters. So 0.07 meter right here. You will get 1.84 times 10 to the power of negative 5 Newton. For F23, equal to KQ2 Q3 over R square, and substitute the value. K is 9 times 10 to the power of 9. Q2 is 5 times 10 to the power of negative 9. Q3 is 5 times 10 to the power of negative 9. Even though this is negative charge, but you don't have to substitute the negative sign right here. And the distance between Q2 and Q3 is 0.04 meter. You will get 1.41 times 10 to the power of negative 4 Newton. And the direction of F21 is to the right, F23 is to the left. So how to find the resultant force? So method 1, since they have different direction, we can use the equation of bigger value minus with smaller value. Okay, tolakkan sahaja keduanya, then you will get 1.23 times 10 to the power of negative 4 Newton. This is the magnitude. For the direction will be to the left because kita ikut nilai mana yang lagi besar, itulah dia punya resultant direction. You can also use method 2. We can find the summation of force but need to consider the sign. Okay, so tambahkan sahaja kesemuanya based on this equation. But if the force directed to the right, then it will be positive. If the force directed to left ataupun downward, it will be negative. So tambahkan semua tapi kena consider dia punya sign based on the direction. And then you will get negative 1.23 times 10 to the power of negative 4 Newton. This is the magnitude. If you use method 2 and you get the negative sign, this shows the direction of the resultant force will be to the left because of the negative sign. Example 3.4. Figure shows 3 charges situated at the corners of a triangle. Q1 is negative 1.2 microcoulomb. Q2 is 3.7 microcoulomb. Q3 is negative 2.3 microcoulomb. And the distance between each charge are 10 cm and 15 cm as shown in the figure. Calculate the magnitude and direction of the resultant force exerted on Q1. So kita nak cari jumlah force yang ada pada Q1 sahaja. Okay, first label the direction of the force. Q1 and Q3, they are going to repel, thus F13 to this side and F31 to this side. Q1 and Q2, they are going to attract, thus F12 to the right, F21 to the left. We can make a X and Y axis right here. Okay, you can see that the force on Q1 is exerted on this quadrant. Okay, kalau saya transferkan kat sini supaya lebih jelas. X, Y axis. And we have F12. We also have F13. There should be an angle right here. You can calculate the angle. So, kat sini kalau straight line, 180 minus 120, you will get 60 degrees. Okay, how to find the resultant force based on this diagram? I hope you still remember how to find the resultant force based on this diagram. So first of all, find the value of force F12 and also F13, then you will get the value of F12 1.78 Newton, F13 2.48 Newton. Then resolve the force in X component and Y component. Based on this XY axis, you can see that F12 is directed to the right on X axis. Thus on F12 it will be positive 1.78 Newton. On Y axis dia tak ada force, so 0. F13 is situated in the middle of the fourth quadrant with angle 60 degrees. Thus, when we resolve it on x-axis, it will be positive 2.48 cos 60 degrees. Then we will get 1.24 Newton. For F13 on y-axis, when we resolve it, it will be on the negative y-axis. Thus, it will become negative 2.48 sin 60 degrees and we will get negative 2.15 Newton. The next step is tambahkan all the force on x-axis. We will get positive 3.07 Newton and tambahkan semua force dekat y-axis. We will get negative 2.15 Newton. So next step is easy because we already know how to find the magnitude and direction. For the magnitude of the resultant force, we will get 3.71 Newton. And the angle for the resultant force, we will get 35 degrees at quadrant 4. So kalau you sketch balik, okay, summation Fx positive, so dia ke kanan positive. Summation Fy is negative value, so it will be on the negative y-axis. The resultant force will be on the fourth quadrant with angle of 35 degrees.